Namaskaram. Welcome to the course Basics of Electronics. In this video, we will be looking into 5 important topics about batteries in electronic industry. First one, what are batteries and types of batteries available in industry? Second one, what are the applications of battery technology? Third one, series and parallel connection of cells to make a battery pack. Fourth one, the safety instructions or precautions for charging and discharging cycle of a battery pack. Last but not the least, fifth one, we'll be discussing on the basics of BMS, which is nothing but battery management system. So let's start. What are batteries and different types of batteries in electronic industry? Batteries are the electronic devices which stores the electrical energy in the form of chemical energy. It consists of a positive electrode, negative electrode and an electrolyte as a chemical between them. Based on these chemicals arrangement and the electrodes arrangement in an engineering form, it will deliver electrical power when it is connected to electronic circuits. Based on the electrodes and the electrolyte chemical used in the manufacturing of batteries, these batteries are categorized into several forms. For example, lithium-ion batteries, zinc oxide batteries, zinc carbon batteries, lead acid batteries and so on. Based on the use cases, these batteries are categorized into two types. One is primary battery, another one is secondary batteries. Primary batteries are those which are used only once and then discarded when they are discharged. Whereas the secondary batteries are those who are rechargeable, which can be recharged and used again. Now let's talk about the various applications of battery technologies. Battery technology means which type of electrode and electrolyte chemical is used in the manufacturing of batteries. Every electronic device which are portable requires a battery to power them. For powering up the various electronic devices based on the capacity of power required, based on the form factor and based on the certain parameters which are related to electrical power delivery, we select the type of technology required for that battery manufacturing. Lead acid batteries are most widely used in vehicles to power the ECUs and also electronic peripherals like a headlight or indicators or even a horn. In current technology of electric vehicles, most of the manufacturers are using lithium-ion batteries for manufacturing the electric vehicles. However, there are some manufacturers who prefer nickel metal hydride batteries for specific reason of their electrical engineering. In mobile phones and laptops, we can see that lithium-ion batteries are widely used. But based on the requirement of certain applications, we can also see that there are other types of technologies being used. For example, in drones, we can see lithium polymer batteries are widely used than lithium-ion batteries. That's how, based on the application and based on the current requirement, we select the technology of batteries. Alright, now let's explore what is the series and parallel connection of cells to create a battery pack. First of all, we need to understand that whenever we are designing a new applications or electronic applications, we have to understand what is the current rating and voltage rating for that entire circuit to work. In that case, we have to create our battery pack as per the requirement. On that time, sizing the battery pack is directly proportional to how we connect the cells in series and parallel combination. So that's why this topic is very important. Now let us understand one thumb rule and remember it for the entire activity. First one is, whenever we connected two series cells, then the voltage will be increased, or you can say a doubled. And whenever we connect the two cells in parallel, then the current capacity or the current delivery will increases. Now let us assume that we require a 5 volt of power supply with 4 ampere hour of current rating. On that case, how do you decide your battery pack? First of all, we need to understand that in market we have a lithium-ion batteries with a 3.7 volt of voltage rating and 2 ampere hour of the current capacity. And how to create a 5 volt power supply and 4 ampere of current rating with this? It's quite simple. Creating a series parallel combination of these particular battery cells. First of all, to increase the voltage, we need to connect two cells in series, which is nothing but 3.7 volt plus 3.7 volt, which is going to be 7.4 volt. Now the same series connection of one more line has to be connected in parallel with this 3.7 volt series combination, which creates the 4 ampere hour of current capacity, because each cell will be carrying 2 ampere hour of current capacity. Now, this particular battery pack is so called 2S 2P. 2S means 2 series, 2P means 2 parallel combination of 2 series cells. This is how simple creating a battery pack for your application. Now this particular battery pack will deliver a 7.4 volt of voltage with the 4 ampere hour of current rating. Now we need to add one power supply or linear voltage regulator to convert this 7.4 volt of voltage into a 5 volt. That's it. This is how the battery packs are created by using the series parallel combination of cells in a specific way. Now let's talk about the safety precautions of a charging and discharging of battery packs. Whenever we assemble cells in a battery pack, we need to understand that these battery packs need to be handled with a very careful instructions. Though they are come up with a very special instructions in the data sheet, most of the people fail to follow them and cause a disaster with the battery packs. For example, charging cycle, discharging cycles and the thermal runway of the battery pack is very important parameters to monitor and control. The efficiency, durability and the effective voltage and current rating of the battery pack is directly proportional to the charging cycle, discharging cycle and thermal condition of the battery pack. That's why these 3 important parameters are very essential to control and monitor for every battery pack. According to a data sheet of the manufacturers, we can identify that what is the charging cycle and what is the discharging cycle, or you can say the constant voltage and a constant current cycle of the charging and discharging process of the battery pack will be identified. And based on that, we have to charge the battery and we have to understand how to discharge the batteries. The constant voltage and the constant current charging and discharging cycle is directly proportional to the SOC of the battery, which is nothing but state of charge. There are special circuits with the integrated controllers which helps us to monitor and control the charging cycle, discharging cycle with a thermistor for monitoring the temperature. However, there are some advanced controllers available in the market which helps us to reduce the overcharge or discharge with some other facilities or features to control the battery pack. Now it is a time to discuss about the basics of BMS. BMS stands for Battery Management System. In industrial applications, it is not sufficient to control the charging and discharging cycle of a battery pack. Alongside, we also need a BMS circuit which controls the various factors more than the safety instructions. BMS basically provides the safety and security for the battery pack in every situation. For example, overcurrent discharge, over discharge of the battery, over thermal runway or overcharging and over discharging. No matter what is the case, the BMS will take care of the battery pack. The fundamental reason of battery management system in the battery pack is to take care of the battery health and battery charge irrespective of the external factors. Some of the high-end BMS circuits in the battery pack will provide the very vital information for the main controller, such as state of charge, which gives you how much percentage of the battery is remaining within that, and also there are some state of health which will tell you when to replace your batteries when they are totally drained out. This BMS is the core reason behind whatever the prediction or whatever the calculations can be done by your electric vehicle to tell you how much kilometer you can travel or miles you can travel with the current state of charge. I hope you enjoyed the process of understanding the battery pack and various features about the battery pack in electronic industry. See you again in the next video. Until then, happy learning. Namaskaram.